We are told to solve the right triangle. Give the lengths to the nearest hundredth. So when they ask us to solve the right triangle, they're asking for side length A, side length C, and missing angle X over here. We're going to solve this right triangle using trigonometric ratios. So let me write that. SOH CAH TOA, just for reference. And remember, SOH is the sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. So what information are we given? Well, we're given this length of 6.5 and this angle of 40 degrees. And let's try to solve for A. We need the opposite, and we have the adjacent side. So what deals with the opposite and the adjacent? Well, if we take a look over here, it's the tangent. The tangent deals with the opposite and the adjacent. So we would write the tangent of 40 degrees equals our opposite, A, over our adjacent, 6.5. Now you might say, okay, that's pretty good, but I don't know what A is. How do I find that out, right? Well, we're going to multiply both sides by 6.5. So 6.5 there, 6.5 here. These cancel out, and I'm just left with 6.5 times the tangent of 40 degrees equals A. And that's exactly what I want. I can now input this into my calculator. 6.5 times the tangent of 40 degrees equals A, and we should get the side length A. So I encourage you, pull out your calculators and work this problem out with me. And make sure your calculators are on degrees and not radians. So we have 6.5 times the tangent of 40 degrees equals, and A is going to be 5.454, and it says to round to the nearest hundredth, so that's going to be 5.45. So we can write that equals 5.45. So A right over here equals 5.45. Awesome, so we were able to solve for A. Now let's solve C. Now we can use the Pythagorean theorem, a squared plus b squared equals c squared. We could solve it that way, but since we've been using trigonometric ratios, let's just continue using that to further solidify our understanding of trigonometric ratios. Now there are a couple ways we could tackle this. We could use the opposite and the hypotenuse, or we could use the adjacent and the hypotenuse. I'll go with the adjacent and hypotenuse just because we know this is exactly 6.5 and this over here has been rounded. So let's use the adjacent and the hypotenuse. What deals with the adjacent side and the hypotenuse? Well, if we take a look over here, the cosine, it's adjacent over hypotenuse. So we would write the cosine of 40 degrees equals our adjacent, 6.5, over our hypotenuse. Now again, you might say, all right, that's pretty cool, but I have this c at the bottom. What do I do now? Well, now we're going to multiply both sides by c. So times c times c. These two c's cancel each other out, and we're left with c times the cosine of 40 degrees equals 6.5. Now we can divide both sides by the cosine of 40 degrees. And we're just left with c equals 6.5 over the cosine of 40 degrees. Now notice, over here, when we had the variable at the top, we ended up multiplying the number times our appropriate trigonometric ratio. However, over here, when we have the variable at the bottom, we end up dividing that number by our corresponding trigonometric ratio. And so when you have the variable at the top, we multiply. When you have the variable in the bottom, you divide. So again, I encourage you, pull out your calculators and work this problem out with me. 6.5 divided by the cosine of 40 degrees is going to be 8.485, so we can round that to 8.49. So this is going to equal 8.49. So we can come up here and we can write in equals 8.49. And just like that, we have solved for length C. The only thing that is missing now is this angle x. What is angle x? What's the value of angle x? Well, we know that all three angles of a right triangle add up to 180 degrees. We know this one's 90. We know this one's 40. We can do some simple math and we can find out that this angle is going to be 50. 50 plus 40 is 90. 90 plus 90 is 180. So right here, this is going to be 50 degrees. And just like that, we have solved the right triangle, giving the lengths to the nearest hundredth. So I hope this video was helpful, helped you understand how to use these trigonometric ratios for solving side lengths and angles. And as always, stay positive.